Okay, so question 6. I'm doing it as an integration question because it ends up with an area, but actually there's quite a lot of everything in here to start with. So the first thing we've identified we need to do, we've got a tangent to a curve at the point P, and it passes through the origin. As soon as we see the tangent, it's all kind of core one way of thinking that the word tangent triggers in our mind that we're going to have to differentiate. So let's start by saying if y is, I'm going to write it like that, 3x minus 5 to the half, we should be able to differentiate this to get dy by dx, which would be a half, 3x minus 5 to the minus a half, and of course we're going to multiply by the derivative of the inside bit, so times by 3. So we get 3 over 2, 3x minus 5 to the minus a half. We'll leave it like that for now, and maybe do something else with it in a moment. Right, now I want to do this properly. I don't want to use this value of 10/3. So what I'm going to say is that the x value at the point P, let's call it P. Okay, and I want to show that my value of little p that I'm working with turns out to be 10/3. So the y value is the square root of 3p minus 5. And the gradient of my tangent is 3 over 2, 3p minus 5 to the minus a half. I don't really like it like that. I might write it as being 3 over twice the square root of 3p minus 5. Is that okay? Because that's what that means, isn't it? 3 over 2 times 3p minus 5 to the minus a half. Right. Now this passes through 0, 0. I know that, that's given in the question. So as it passes through the point 0, 0, it must be y equals mx. That's the equation, isn't it? The c is 0. So it must be that y equals m 3 over 2 root 3p minus 5 times x, which is p. And so if I rearrange this now, I need to try and solve this to get p on its own. I'm going to multiply by 2 lots of root 3p minus 5. That gives me 2 times 3p minus 5 is equal to 3p. Is that okay, that step? I've multiplied by the 2 and multiplied by the square root, which left it not square rooted. So 6p minus 10 is 3p. This is all looking quite encouraging now. So 3p equals 10. P equals 10 over 3. And I think that's the neat way of doing it. And it was a good spot for P here was that we were heading in the right direction, weren't we? To differentiate first, and then to spot that, because it goes to the origin, y equals mx. There's no value c. Right, show the x-coordinates 10 over 3, and hence find the exact area of the shaded region. And now let's look back at our graph there. The key to the shaded region is that if we find the area of the triangle and then take away the area underneath the curve, that would leave us with the shaded region. That's right, isn't it? So we need to think our way through that. Let's work out a few things. I'm just going to do a little sketch of that diagram so that we can see what's going on. We've got a line there, we've got a curve that does something like that, and That's the point 10 over 3. This is the point P. We're going to need to know some other things that are going on here, aren't we? We need to know, if we're going to work out the area of this triangle, we need to know the height of the triangle. So I need to find that y value. So at P, y equals, what was it? We had it up here, didn't we? Root 3p minus 5. So it's the square root of 3 times 10 over 3 minus 5, which I think is just root 5. So that top value is root 5. That will help me work out the triangle. What else do I need to know about? I think I need to know, if I'm going to integrate this curve to find this area underneath the curve, so that I can take it away, I need to know what this point is. And this is the point where the curve hits the axis. Let's call that, for the sake of argument, let's call it the point B. At the point B, that is where my curve, y equals root 3x minus 5, equals 0. And that's the point where x equals 5/3. I don't know why I've double underlined that. It was put off by the window magically closing itself. Okay. Right, so let's think, we're ready to do some area stuff here. So the area of the triangle is 1/2 times the base times the height. So then the triangle, of course, is this bit here. We don't forget the simple stuff, like finding the area of a triangle, 1/2 base times height. That is 5 root 5 over 3. I don't know where that's going. There's no reason that that's what it just is. And so the shaded area there, the integral area, is the integral from, I only need to go from b, which is 5 over 3, to 10 over 3, and I'm integrating my function, which was 3x plus 5 to the power of 1/2. 3x minus 5, sorry, to the power of 1/2. So let me integrate that. That would be, now remember when we do integration between limits, we need to add 1 to the power, which would make it 3 over 2. We need to divide by the new power, and also multiply by the coefficient of x from there. So that's divided by 3 over 2 times 3, between 5/3 and 10/3. It's a little bit complicated, but you think we've done all the core 4 integration. This is nothing compared to some of the core 4 stuff. And so I'm going to tidy this up slightly. What's this 9 over 2 down here? So we're divided by 9 over 2, so that's 2/9 of 3x minus 5 to 3 over 2, between 5 over 3 and 10 over 3. Now, our calculator will give us an exact answer for this, so we're just going to really carefully type things in here. It's not bad at all. It is 10 times 3 times 10 over 3 is 10. Take away 5, so that's 5 to the 3 over 2 minus 2/9 of 5 minus 4. Well, that's just 0, isn't it? So that's there. Now, here we've got 5 to the 3 over 2 is root 5 cubed, which is 5 root 5. So that is 10 root 5 over 9, I think we should have ended up with. And so I'm nearly out of space on my page here, but therefore the total area, the shaded area, is, remember we were doing the triangle, 5 root 5 over 3, take away the integral, 10 root 5 over 9, have I done that right? Which I think gives me 5 root 5 over 9 as a final answer. Square units, and I haven't actually got the answer in front of me. It's around somewhere. Are we agreeing with that? You want me to check that that's right? 5 root 5 over 9 is what I got last time we did it as well. So it's all looking good. And that's maths.